Hello guys, we are going through 5.5 to 5.7 talking about trig graphs. Looking at these first ones where we're determining the amplitude, right? So we can look at an equation and we can determine the amplitude, right? And so all these first few are going to come from kind of that default like trig equation template that we talked about, which is this right here, right? We have this template and again, these letters A, B, and C, or numbers being in these positions affect what the graph looks like, right? And obviously, again, doesn't have to just be sine. It can be any trig function. And there would also be like a plus d at the end here, but again, we haven't talked a ton about that one in class. So that would just be a vertical shift. But again, you won't see anything on that on here. So looking at number one, the amplitude of y equals sine of x, right? So you don't see any extra values in there. So that would just be talking more about like the parent function of sine, right? And so, right, normally where we would look for the amplitude is a coefficient right after the equal sign in front of the trig function. And I don't see one there, right? We talked about this. When that happens, the amplitude is equal to 1, right? Meaning when I draw my graph of my sine, my wave will go up to 1 and down to -1, right? So that wave height would be just 1. Okay. Number two, amplitude of 4 times the cosine of 1/2 x. Okay, so we see a couple values in here. So again, it's knowing that this 4 is the one that relates to the amplitude. So again, my amplitude would be 4, right? Meaning, and again, compared to the parent graph, my waves would be 4 times as high as they would be on the parent graph, or again, that would just be going up to 4 on my y-axis. So that's amplitude. 3, 4, and 5, determine the period. Okay, now period has to do with my b value, okay? But again, it's not just whatever numbers that in that b position, that coefficient of the x is my period, right? We do that, it has to do with that value, right? But it's 2 pi over that b value, right? So again, I look at this, period of -1/3 sine of x, right? So what value is my b? Again, I don't see a value there. So I'll just say my b value is 1, but again, that is not my period. Calculate my period, I do 2 pi over 1, which is just 2 pi, meaning this would be just the same amount of a period as my sine parent graph. It would take 2 pi to make one full wave or one full cycle of my wave. Okay, so 2 pi is my period there. That's kind of my default period when you don't see a b value written. Number 4, period of -3 cosine of pi over 2 x. Okay, so again, for this one, we notice that the value with my x, my b, is pi over 2. So that's my b value. And then again, that's not my period though. To calculate my period, I do 2 pi over that. And now 2 pi over 2, that can be confusing, right? Because that's kind of a fraction within a fraction. So we said dividing by a fraction is the same as multiplying by its reciprocal, right? So multiplying by 2 over pi would be the same as dividing by pi over 2. And so when I do this, right, I think of this as 2 pi over 1. And again, if I have a pi on top and pi on bottom, those can kind of cancel out. And so I would just be left with 2 times 2 over 1, or just 4, right? So my period here would be 4, meaning it would be, like on this graph, you'd see the normal like x tick marks of 1, 2, 3, 4. And that's how long it would take to make one full wave cycle of cosine. All right, lastly, period of -5 sine of 2 pi x. Again, 2 pi being my b value, okay. And again, that's not going to be my period of this either, even though that's kind of the value, the same value we use to calculate this, okay. So 2 pi over my b value, which is also 2 pi, would just be 1, okay, right? Something over itself just equals 1, right? So those would be the periods of those. Moving on down, number 6, phase shift of -4 sine of x minus pi over 2. So again, phase shifts have to do with my c value, right? This is going to be a phase shift is another word for a horizontal shift, shifting my wave left or right on my graph, okay? And so again, that's if there is this value subtracted, right? We said that moving right is what happens when we have a subtraction, and a moving left is what happens when I have a value being added, right? So we need to know for phase shift, it's not enough to just say, oh, it moves pi over 2. We have to say the direction too. Okay, so pi over 2, okay, minus, right? So two things with that. I see that, again, my value is pi over 2, and I see that it's minus, which means it's going to move right pi over 2 units. Okay, so that's really all with that one, just looking at that. If there would be a b value that can affect this, but thankfully in these problems there is not one. Anyway, so then we look at this. Plus means left, right? So x plus 4 pi. So I'm going to be moving left that amount of 4 pi. All right, simple ones for phase shift. All right, moving on down. Now we're looking at these. Find the exact value of the expression, okay? Now again, we talked about a couple ways you could do this, okay? So I'll show those couple ways here. You can use a unit circle, okay, which would be great, okay? You could also use your calculator to find these inverse trig functions, right? And again, how we've done it in class using degrees, right? Finding our answer in degrees. So we look at this and we see inverse sine, that's how we'd say this, of 1. So what we're really asking ourselves here is what angle has this value as its coordinate? Okay, and again, coordinates specifically referring to, on my unit circle, like these x and y coordinates, like of the points that would be here on the coordinate plane if I was to graph this angle in standard position, right? And so what we also have to know too is, does that relate to the x or the y value, right? For sine, cosine, and tangent. And again, sine relates to my y value, cosine relates to your x value, right? You're going to be given this on your test, okay? So knowing that, what I'd be looking for here is, right, so my answer for these is going to be an angle. So it's asking what angle, what degree angle has a y value of 1? Okay, so I want to look at my graph, and again, usually I start from 0 and I move up from there, okay? So when I look at this, like I'm looking at my y coordinates as I go up, and I get to my 90-degree angle. We see my 90-degree angle has this y coordinate of 1, meaning that that is an answer to this, okay? So 90 degrees is an answer to this, okay? And again, there are other angles that would relate to, right? Not as many right on my unit circle, but technically you could also say negative 270, right? That could also be a y coordinate of 1, right? So that could also work as an answer. Okay, then looking at number 9, we have inverse cosine of negative 3, square root of 3 over 2. So again, for this one, kind of that's our key question we're asking ourselves. What angle has that value as its coordinate? But again, for cosine, we know cosine relates to my x value, right? So it's more looking like what angle has an x value of 3 pi, negative 3 pi over 2. Okay, so again, looking at my unit circle, I look over this. Again, negative x values would be over on this end of the coordinate plane. And so I see a couple, right? I see 150 degrees, I see 210 degrees. Both have this negative square root of 3 over 2 as an x coordinate, right? So there we go. I could say 150 degrees, I could say 210 degrees. And now again, I did those using my unit circle pretty simply, right? You can still do them pretty quick, but I know a lot of you guys still prefer using your calculator, which I understand. So yeah, using these in your calculator, again, because you won't find 1.2 on your unit circle, right? So this requires you to use your calculator, right? Again, making sure for these directions say it, calculator in degrees, because that's how we're getting our answers. So calculator going to mode here, making sure we're in degrees. And then, so inverse tangent of 1.2, right? So that's second tangent, right? Getting that inverse tangent in there of 1.2. And so I get an answer of 50.19. And so again, what does that mean? Well, that's the angle measure. That's the angle measure of an angle with a tangent value. Again, tangent's the ratio of y over x, so a little bit harder to calculate, especially for my unit circle. But that's the angle that has a ratio of y over x that would give me 1.2. All right, then looking at 11, 12, again, a little bit trickier here using these composite trig functions, right? So it's kind of a trig function within a trig function. So again, with these, we want to start inside out, looking at the inside first, kind of thinking of what we have in there. Our answer is going to be kind of this normal trig function, kind of using that, okay? So again, what we have to remember here is when we take any inverse trig function, like these up here, the answer to that is an angle measure, okay? So this right here, right now, the tangent, inverse tangent of 6/8 is some unknown angle, okay? So we're just going to define our angle that way. Our theta is going to equal to the inverse tangent of 6/8. And again, what you could do is go into your calculator, do the inverse tangent of that fraction, and get the actual angle. But again, that could help me. But again, I told you guys in class, I do want you guys to sketch this out and solve it a different way than just using the calculator. Okay, so here's what a sketch of this would look like. Again, think about this. When I'm given tangent, right, thinking again of SOHCAHTOA. So thinking of SOHCAHTOA, right, when I have tangent of, and I'm given a ratio with that, that's telling me the length of the opposite and adjacent side of a triangle, right? So this would be telling me like this pertains to like a triangle with an opposite side of 6 and adjacent side of 8, okay? So if I think about what that looks like as like a sketch on my coordinate plane, I could sketch a little triangle, right? And positive values, right? So I'm going to draw this in quadrant 1. Okay, so then again, thinking about kind of getting acclimated here with my triangle. Again, this would be my hypotenuse, right? My diagonal side across my right angle. So I don't know the length of this side, but I could say that this, and again, if theta is kind of the angle kind of touching my origin here, closest to that, my opposite side of that would be this. And so again, referring to my ratio, opposite side is length of 6, adjacent side is length of 8, okay? And I don't know this side. So then, yeah, so that's what I'm given from this, okay? Is just if it's an inverse tangent of this, this again could be some angle that we could very easily find the measure of using a calculator. But again, we're just going to leave that out because that's not necessarily a step that would help me to solve this using a sketch, okay? So what I can do instead is kind of say, okay, my answer is going to be the cosine of whatever that angle is equal to, again, it's going to be another ratio, okay? And again, we have to think about for cosine, how do we find cosine of something? Well, cosine is adjacent over hypotenuse, right? And so adjacent over hypotenuse. So I want to think about, again, what do I kind of know in my triangle right now? And what else do I need to know to be able to fill in a ratio with these values? And so I know my adjacent side, right? I know my adjacent side from this tangent ratio is 8, right? So my adjacent is 8, and I can put that there. But then my hypotenuse, I don't know that side length yet. That's up there, okay? So again, what we can do to find that though very easily, right, just like we've done before, if you know the two side lengths of your right triangle and you still need to know your third one, that's where Pythagorean theorem comes in, right? So 6 squared plus 8 squared equals c squared, right? My hypotenuse is my unknown, okay? I can solve this pretty easily, right? So 6 squared, 36, 8 squared, 64. 36 plus 64 gives me an even 1 hundo. And then I would take the square root, right? So square root that. And so square root of 100 is just 10. My hypotenuse is 10. And that is that side length. And again, why is that helpful? Because I need to know the hypotenuse length to be able to give a full cosine ratio here, right? So if my cosine of this, whatever theta is, again, whatever this would result in being, cosine of that angle would equal 8/10, right? Based on my diagram that I have over here, okay? So the process with this, again, is kind of looking at what's in the inside, sketching it out, thinking about what you still need to know, but able to answer the second part, and going from there. So if we do the same thing with number 12, this is saying the inverse sine of 5/6. So again, think about this, and that pertains to an angle, so that whatever theta is, it's some unknown angle, is equal to the inverse sine of 5/6. Okay. So again, another positive ratio, so that's nice. So I can set up, again, another triangle on the coordinate plane, again in quadrant 1 because we're dealing with a positive value. And so again, thinking about what would these tie in with on my triangle here, right? If theta is on the inside there. Well, again, with sine, sine is opposite over hypotenuse, right? So this opposite over hypotenuse. So my opposite side of theta is 5, and my hypotenuse is 6. So I know those for sure. And so again, let's think about what do I need, what side lengths do I need to find my answer, right? Because my answer is going to be secant of whatever angle that ends up being is equal to what? It's equal to, well, this is tough, right? Because SOHCAHTOA just relates to sine, cosine, and tangent, not necessarily my reciprocal functions. But again, we're remembering that secant is the reciprocal of cosine. Cosine is adjacent, over hypotenuse. So then flip that around, secant would be hypotenuse over adjacent, right? And so then let's look at that. So I know my hypotenuse is 6, so I have half of what I need, but I don't have this adjacent side, right? This other side, That's not my opposite side or my hypotenuse that I need to know. So again, I do need to do Pythagorean theorem to be able to figure that out, right? So that would just be, again, set it up right. So it's 5 squared plus b squared equals 6 squared, 6 being my hypotenuse on the other side. So that would be 25 plus b squared equals 36, okay? I subtract 25 from both sides and I get 11. Take the square root of both sides. Again, not interested in a decimal. We want to leave it in radical form because that's what's done in trig, right? And so square root of 11 is my unknown side length here. So then what do I do with that? Again, that's my adjacent side. Then I need to complete my ratio here. So the secant of theta in this diagram would be 6 over square root of 11, or again, rationalizing that would be 6 square root 11 over 11, if you did rationalize that. Okay, the back involves writing the equations of these parent graphs, okay, and it can be a little bit tricky to tell. But again, this is something I want you guys to know about, is the shapes of these parent graphs of these trig functions, okay. So again, you don't necessarily have to go right in order, right? Maybe starting with the ones that maybe are most familiar, that we've done the most with, and that is sine and cosine, right? So again, it's what we need to know to be able to answer these the right way is being able to tell the difference between the two, right? So I know for sure that this one is going to be sine. Again, the equation of a parent function is just very simply just y equals the trig function of x, okay? And again, how do I know that? Well, I know that sine goes through the origin, right? It's one continuous wave, comes up and then comes down, and then 2 pi's, its period length, so that is one full cycle. Okay, so that 15 I know for sure is sine, which means my other one that's just a continuous wave without like any asymptotes would be cosine, right? This has to be cosine, again, not starting at the origin, but starting at 1, and then going down, going back up, right, and taking 2 pi to make, again, one full cycle, but that is a continuous wave, similar to sine, just starting in a different place, having a different y-intercept, okay? All right, so got my 2 basic ones out of the way. So almost having like a bank up here, right? So I've used my 2 basic ones. So what I have left is tangent, cosecant, secant, cotangent. So again, just kind of going through the rest of these. I know for sure that the ones that we learned about most recently were tangent and cotangent, right? And those ones were the ones that kind of were more, the distinct quality of these relating to the other trig functions is that the period is shorter, right? It only takes 1 pi to make one full cycle of cotangent and tangent, versus all the other graphs, it takes 2 pi to make one full cycle. And again, the shapes of these are different too. It almost resembles like a cubic graph. And so again, just remembering this stuff too, okay? So we talked about some distinct qualities. Tangent is going to be this guy because tangent, again, goes through the origin, and we said we read a graph like we read a book from left to right. And so from left to right, it's going low to high. So that's characteristic of tangent, okay? Whereas the one right below that, right, also of similar, like a negative cubic graph shape, okay, but not through the origin, high to low from left to right, and again, that 1 pi period, right? So tangent and cotangent are the ones that are like that, okay? And then we have these guys, okay? It's cosecant and secant, which one's left? And again, remembering too, what's helpful to remember is cosecant ties in with sine, secant ties in with cosine, right? They're the reciprocals. And so what can really help? Again, a couple things. Like let's just say you had no idea which one's which, okay? What we can do for these, right? I should be able to draw, right? Like I should be able to draw the regular trig function kind of on the same graph as this. And you remember it has like those minimum points and maximum points of these curves are shared with the reciprocal function, right? So for this one, I think about like, would cosine work there? Well, again, think about cosine. Cosine starts up at 1 and then kind of goes down. If I like sketch that shape on here, it wouldn't really have any like shared points with that, right? Whereas if I drew sine, sine would have shared points, right? Coming up here at 1 at pi over 2, -1 at 3 pi over 2, okay? So because I can draw kind of sine and have it have those shared points with these curves, that clues me into the fact that it is cosecant. Okay. And then process elimination, right? So I can get rid of this one. The only one left is secant, okay? But again, let me just show you one other thing that you can do. Just if you're feeling like, oh my gosh, this is a lot to remember. You can always graph, okay? You have your calculator, okay? But again, the only thing is on your calculator, you do not have, especially if you have a real old one like me, you do not have the reciprocal trig functions on there, okay? So you couldn't just type in secant of x and have it graph that. So again, we talked about this. You would have to do 1 over cosine, right? Because that's the reciprocal of cosine. And again, we talked about how you can adjust your window, so my window is not going to be perfect. And in fact, I'm glad I showed it this way because look, my calculator just does a straight line. That's definitely not what the graph of secant looks like. And my issue is that if you're doing this, and I said it at the top, calculator in radians, right? So if you get a straight line like that, that is not right. And so again, if you have your calculator might do a weird graph like this, okay? And those are kind of almost showing like the asymptotes in a way. So I don't love how it graphed this, but basically like looking at these curves, right, kind of being in the same place. The big characteristic with secant is, again, it has that shared 1 being its y-intercept, right? And so if I drew cosine in here. So anyway, so those are our 6 parent graphs that we need to know. All right, lastly, just 2 more, graphing these, okay? So it's asking us to sketch 1 period of the parent graph and 1 period of the function that's given on the same grid. Make sure clear points are drawn in the graph, okay? And our y-axis is labeled appropriately, okay? And if we want to, I'm not going to use my calculator here necessarily, but you can do that as a backup option too. Okay, and again, hopefully you label your parent graphs right on the previous page because you can use that to help with graphing your parent graphs, right? So again, we want to think about this because cosine, right? We talked about how the parent graphs, the default graphs have an amplitude of 1, meaning they're only going to go up to 1 and down to -1. That is the wave height, right? So +1, right, for cosine. I'm beginning to draw my parent graph here. I'll do that in this nice, lovely maroon. So it starts up here at 1 and then goes to 0, -1, 0, and 1. And all of those points kind of happening on these tick marks, starting at 0 and going half pi every time. So that is what a cosine parent graph looks like. That is definitely not a great line, but we'll roll with it. And then again, I want to think about then, how does this -4 being added into it, how does that affect the shape of this graph? And what is that going to do? And so again, I'm going to need to add some extra tick marks here on my y-axis because what that is going to do is that is going to affect the height of my graph, and it's also going to affect something else. But yeah, my y values here are essentially going to be multiplied by -4, right? So so 2 things from this. Instead of being at 1, this would be at 4, but it's also going to be moving down here to -4 because again, this negative out in front denotes a vertical flip, meaning it's kind of, instead of being like a smiley face type thing, it's going to be a big frowny face. Okay, and so that's how that looks. So almost thinking of it again, it's multiplying your y values by -4. That tells you where the points are, right? So negative, instead of being at 1, it points at -4. Instead of being at 0, well, it's still at 0, right? 0 times -4 is still 0. Instead of being at -1, it's now at +4. 0 times -4 is 0, and then again 1, -4. So this graph will look more, it's a little better. Going to look like that. Going up to 4 and -4, okay, being vertically flipped because of that -4 in the amplitude position. Okay, and then last one, number 20. Parent graph is sine, right? So let's sketch that. Sine parent graph, again, going from 1 to -1. Again, sine, different shape, right? That's cosine. Sine is the one that starts at the origin and goes 1, 0, -1, 0, right? So sine kind of going like that. Okay, again. All right, and then again, thinking about this, what is added in my equation? Well, it's being, I guess it's subtracted, right? But the additional value in here is this minus pi over 2, right? So that would affect a phase shift, right? That'd be a phase shift because that's in that C position in my equation. Okay, so phase shift, again, so I want to think about what's my direction and how many units is that moving. So pi over 2 means I'm moving right. Well, the minus means I'm moving right, and I'm moving pi over 2 units, right? And so again, I think about my x-axis. Pi over 2 is just one tick mark, right? So basically this means that I'm moving every one of my points to the right by 1 unit from where it was in the parent graph. Okay, so this origin point moves over 1 tick mark to pi over 2. This point from pi over 2 moves over to pi. So every point just moves over to the right 1 tick mark, right? So this one coming over here, this one coming over here. And it would be, again, the same shape, just like that instead. Okay, so similar looking graph, just bumped over. All right, guys, there it is. Trig graphs. Thanks for watching.